Alright, so this is Notes 7.7, and I apologize because I started making this video, and then we had internet trouble, and so I've already started on the notes, so instead of just doing another paper, I'm just going to go through them. Alright, so example 1, give the linear equation 4x minus 6y equals 12, and answer the following. So I went ahead and changed it into my slope-intercept form. Alright? So I subtracted my 4x from both sides, left me with negative 6y, and then, which left me with negative 4x plus 12. And then I need to get rid of that negative 6, and since it is a coefficient to the y, that means it was multiplication, so its inverse would then be division. So divided both sides by negative 6. Remember, I have to divide the whole thing by negative 6, not just part of it. So negative 4 divided by negative 6. Negative divided by negative is a positive. And 4 is 6 simplified to 2/3. Okay. X plus my 12 divided by negative 6, which is negative 2. You could have done plus a negative 2 if you wanted, or just minus 2. Okay. So let's look at the questions. Circle 1. The original equation is in slope-intercept form. Slope-intercept form is y equals mx plus b. And it wasn't in that form. Now, we haven't used this word standard form very often. But standard form is when it's written like that 4x minus 6y up there. Alright? So this is standard form. We're going to make a note to what standard form looks like since we really haven't talked about it. And standard form is when it's ax plus by equals c. Ax plus by equals c. That's our standard form. Kind of makes sense. A is a coefficient, b is a coefficient, and c is my that constant. Alright, so does the graph of this line cross the y-axis above or below the x-axis? Above or below the x-axis? I think it meant y-axis here, so sorry about that mistake. Go ahead and change it to a y-axis. So we had a slope of negative 2, a y-intercept of negative 2, and that is definitely below, okay, because it's negative. What is the constant rate of change? Remember, another word for constant rate of change is slope. So that's going to be in the m spot, which is 2/3. What is the y-intercepts? 0, negative 2. Went ahead and put it in my coordinate form. As x increases by blank, the y blank increases or decreases by blank. Well, our slope is positive, so I know that because my slope is positive, it's going to be an increase for both of these, okay, because they're both positive. And so my 2 is a change in y, and I'm getting that from my slope up here. And my 3 is a change in x, so my x value increased by 3, and my y increased by 2. Does this equation represent a direct variation? And the answer is no, because in order for it to be a direct variation, a direct variation is in the form of y equals kx. Okay? And y equals kx, we have plus 0 or plus nothing there. It could also be minus nothing, minus 0. But, so no, because the y-intercept isn't 0, 0. I have something after that, a negative 2. Alright, so this is where my video had cut out last time, so let's look. Write the equation of a line that's parallel. So I'm going to make a note that that means same slope to the given equation and passes through the point 3/8. Okay? So I know that my slope, my m, is going to be 2/3. Alright? And I know that this is my x and y. Now we're going to look at two different ways to do this, and we have consistently looked at the same way. But let's look at that first same way, and then we'll talk about another way. So y minus y1 equals m x minus x1. So y equals my y1, which is 8, y minus 8. M is 2/3. My x is 3. Oops, sorry. Ooh, I'm making this video early before school. So maybe, I know how I am with mornings. If you're one of my students, not my shiniest point of the day. Okay, I'm going to distribute that 2/3, so 2/3 x. I had some of you who, you're only distributing to that first thing. Be sure you distribute to both, okay? So bring down my subtraction, and we're going to do 2/3 times 3. And I also had a student who came in and talked to me about reminding how to multiply without a calculator, those fractions. So 2/3 times 3, I'm going to stick it over 1. And we can cancel those 3's, leave me 2 over 1. You can also do, to multiply fractions, you know you got them top times top, 2 times 3, which is 6, and bottom times bottom. And 6 divided by 3 would then be the 2. Okay. If you're one of my online learners, know that if you have any questions like that, just shoot me an email, or I can meet with you over Teams, because there's a video component. Just let me know. All right, so there's our equation using that y minus y1. But I did have a parent that talked to me, and I agree with them, that there's another way to do this problem, and that we haven't looked at very often. And that other way is using just my y equals mx plus b. So I do have a y value, so I'm going to plug that in. And then I do have an m value. And I do have an x value. I want you to notice, this is kind of where we're at. Okay, we had this kind of set up just a little bit, except for we kept an x and a y. And we're going to talk about why I like this way better in just a minute. But if you like this way, that's okay. So 2 plus b. My whole goal is to figure out what b is, so I'm going to subtract 2. And 6 equals b. And then I have a slope and a y-intercept. And then I can rewrite my equation. Y equals 2/3 x plus 6. The reason I like this way better is it's one step. One step solves for b and puts it in my y-intercept form. And that's why I like this way better. It's also, you are given this on your mathematics chart. And so the more that you use it, the more that it'll get ingrained and help you out. But this way works too. And I believe we looked at this way in 8th grade math in my class. So either way works. As long as you show me what you're doing in your process, I'm good with whatever way you do it. All right, let's look at number 8. Write an equation for a line that's perpendicular. We have to remember that that means our slope is opposite reciprocals. And I did abbreviate. If you need to write that out, you can, for the given equation. So if my slope was 2/3, my slope is now going to be -3/2. Okay, so flipped it, opposite, gave it negative instead of positive, and then I did the reciprocal, which is flipping that fraction. I'm going to go ahead and just do this way. I'm not going to do it both ways. If you want to do it the other way, I am perfectly okay with that. Anybody who has been in my class for any amount of time knows I'm pretty okay with you working a problem. Whatever way works for you, as long as it is accurate and as long as you can show me how you did it. Because I do want to see when you make mistakes, where you made mistakes. And sometimes that's hard to see if you don't show me your work. Add line change of sign makes this plus 13. Quick reminder, just because I've been tutoring a couple of you, if you see that minus and the negative, go ahead and add line change of sign. it makes your life easier. 90% of the time. Okay, so I have a negative and I have a subtraction. So I'm going to go ahead and change this to add on and change sign also. So I have negative 3/2 times 2. So I'm just going to do the 3/2, times 6. Ooh, I told y'all. Okay. So this can cancel, but it's going to leave me with 3 left over. Okay, because I can only take out the 2. 3 times 3 is 9. And negative times a negative is a positive. Subtract 13 from both sides. There we go. Okay, let's look at the back. Write the equation of each line described in slope-intercept form. Okay, so we are looking at a graph. So to find our slope, we're going to do rise over run. I know some of you really dislike when they don't have the points for you. So a lot of times I look at my y-intercept first because a lot of times they're nice to us and have that be a nice, clean, pretty number. And then I look for where it passes through corners. Except for this line is not very nicely drawn. We're actually going to skip this one because this line is not drawn very clean for us. It's very tough to see where it's wanting us to see. But let's just remember that our slope is rise over run. And that's going to be our M. And let's just remember that our y-intercept, which we can look at our y-intercept here, assuming that that's going right through, it's going to be 4. I'm sorry, it looks like it's going through. Yeah, no matter what, that's not the prettiest line for us. So we're just going to leave it at that. All right, let's look at number 3. Slope of negative 1/2. So I already know my M. That's always nice. And we have that point, just like we've been doing. So my y value is 1. Go ahead and label those because I make silly mistakes sometimes. My x value is negative 4. Oh, that stays x. So this is going to stay as y minus 1. I'm going to go ahead and take care of that. Distribute that 1/2 out, or negative 1/2, sorry. Plus negative half of 4 is 2. So it's going to be a negative. So I'm going to go ahead and change that to a subtraction. Add 1 to both sides. And I'm left with y on the left. Negative 1/2 x. Negative 2 plus 1 is just still minus 1. And guys, you can always plug this point in. So go into your calculator and type in 1 equals negative 1/2 times negative 4 minus 1. Push equal. And because our calculator will tell us that it's true or false. So it's a nice little check, or you can do it by hand. So vertical line. So we're looking at our bucks. Anytime I see the word vertical or undefined, I need to think bucks. So I know I'm going to be looking at x equals. And my x equals negative 2. We have a y-intercept of negative 2. So I know my b is going to be a negative 2. Yay. Alright. And so we're going to look at our x-intercept and our y-intercept. Alright, so that gives us 2 points. Sorry. So we have 0, negative 2. And our x-intercept is 6, 0. So we can find our slope by doing, I had a student who told me that they like to just plot those points and do rise over run. That's okay if you have a graph. if that's how you want to do it. Some people like to put it into a table and then look at the change in y over the change in x. That's also okay. We're going to look at y1. We're going to look at our differences in our y's over our differences in our x. So y2 minus y1 over x2 minus x1. So y2 is 0 minus negative 2. 6 minus 0. And then change sign gives me 2, 6, 1/3. And from there I have my m. So y equals 1/3 x. And I already had my b. So no extra work needed. Alright. The distance required to stop a car varies directly, which tells me this is a direct variation. Alright. In one experiment, a car traveling 60 miles per hour required 250 feet to stop. Okay. Write an equation that can be used to find y, the distance required to stop when it's traveling x miles per hour. So we have x and y, and we know that when it's going nowhere, when we have 0, it's going to be 0. Mainly because of direct variation, also because of the situation. And told us here that our y is the distance, and our x was our miles per hour. Okay, so up here we had 60 miles per hour, and we had 250 to stop. So write an equation. Alright, so we're going to find our slope. So change in y over change in x. Change in y is 250 over change in x, which is 60. Let's do a little mental math. 6 goes into 25 4 times, which is 24, with 1 left over, 1/6. 0.16 repeating. So we're going to say, I'm just going to keep it as 4 1/6. So it's a little more accurate. So y equals 4 1/6 x. And I know there's not going to be a plus anything because it was a direct variation. If you wanted to put this as a decimal, you could have. If you wanted to put it as an improper fraction, that's okay also. If you wanted to keep it over 25 over 6, that would have been okay. Alright, how many feet are required to stop a car when it's traveling 25 miles per hour? So now I want to know this. So that's my x value. So I'm going to go back to my equation. I'm going to plug it into my x. Now some of you plug it into the wrong one, I've been noticing. You've been struggling with which one to plug it into. Okay, so I'm going to do this on a calculator. So when I multiply it on a calculator, I get y equals 104 and 1/6 again. And that's going to be our distance it takes to stop. So, sorry, let's put it as feet. Alright. If you haven't turned in your homework from 7-6, please turn that in now. You do have homework over 7-7 tonight. Please do it. Tomorrow we're going to have a quiz in class. And then Wednesday, you have a test over this. Alright, if you have any questions, send them my way.